Now as promised, let's create this Geneva mechanism from scratch. Now what is this Geneva mechanism? Geneva mechanism is the most commonly used mechanism for producing intermittent rotary motion. It is characterized by alternate period of motion and rest with no reversal in direction. It is also used for indexing, like rotating a shaft through a prescribed angle. Other applications of Geneva drive includes automated sampling devices, banknote counting machines, indexable equipments like tool changers in CNC machines, and many more. So let's create this particular assembly. Now here, as you can see, in the browser itself, we are having 4 different components. First is the follower, which is a driven component. Then we have a cam, which is driving the whole assembly. It's a driving component. A pin, which is attached to the follower, and a pin which is attached to the cam. So basically we can say we have 2 basic components, follower and cam. So we will start with the follower. So for that, let's create a new design. And as I told earlier, always start with a new component from the assemble toolbar. Let's give the name as follower. Now here, let's hide all the other components and let the follower be visible. So as you can see here, this component is clearly having circle as the major sketch entity, and out of the circle all these shapes have been carved out and the component, the follower, is made. So what we will do, we will create a sketch on the horizontal plane, invoke the circle command, and this assembly is not 2-dimension. You don't have to worry about providing dimensions here and there. Just go with the flow. Let's create a line. Let's trace the origin from here. Let's make it coincide with the origin itself. Let's make another line over here. Let's say at angle of 54 degrees. Invoke the mirror command. Select this line. Select the mirror line. Click OK. Let's convert these two as construction line. Let's create another circle somewhere over here. And make it tangent to this and this one. Let's convert this to construction as well. Now again, make a circle from the center point of the construction circle that we have created and give any dimension. Now create a slot, center to center slot on this line till this intersection point, and let it be of any width. Now what we are planning to do here is we are trying to recreate this particular section of the component, this one. That's why a slot has been created. Now create a circular pattern. Double click on the slot to select all the 4 objects of the slot. Select the center point, give quantities of 5. And why 5? Because we are having 5 symmetrical or basically similar sections in this component. Now what we will do, we will try to recreate this particular section of the component. Now for that, let's trim this, and this. Let's remove this one also, and better create it as a construction line only. Again invoke the circular pattern. This time select this particular arc, Select the center point and provide 5 as the quantity. Now all that is left to create this component is to trim the unwanted areas. So we are going to fast forward this particular section. Since everything is trimmed, finish the sketch and take the reference from this pre-made assembly of how much we have to extrude. So we have to extrude to 5 mm. We are only taking reference of how much press pull command we have to use, up to how much we have to extrude a 2D sketch to a 3D model. That's the only reference we are taking with this pre-made model. Let's select this one. Press pull 5 mm upwards. So our first component, the follower, is completed. Now for the next one, that is the cam. Activate the head assembly. New component. Let's name it cam. Now for this, what we will do, we will make the sketch of the previous component visible. And let's create a sketch on this plane itself. And from the previous component, if you can see the circle, the construction circle, we can project it. This we have discussed earlier in one of the sketches. This one, click on OK. So it's been projected to the sketch that we are creating right now. Now again, create a circle from here. Let's try to make it coincide with the arc over here. Make one more circle. And a small circle over here. So right now what we are trying to do, let's hide the follower for now. We are trying to recreate this particular component, the cam one. For that we are creating this profile. So for that, let's create one more circle over here. Just trace the origin. This circle corresponds to this particular pin which is made on the cam itself. And what this pin is going to do, as you can see, this is having contact with the follower and it is rotating it. So this is very much important in this assembly, and it should not be more than this gap. So let's check the gap once between these 2 points. It's 6.221. So we cannot make it more than this one. Invoke the circle command. Just trace the origin. Let's make it 5 only. Now we have to create this particular section of the cam. So for that, what we can do, we can create a line anywhere from, let's say, here. Trace the origin. And this one. Let's make it tangent to the circle. This one also. Then let's make it horizontal, vertical. Click on modify, provide fillet. I think this much would be sufficient. Press enter. So we are almost set for the cam, but here we have to generate this particular profile. So for that what we need is a 3-point arc from, let's say, somewhere over here to here. Just trim the unwanted areas. And we are almost good to go. Just finish the sketch. Select all this. Just switch off the follower for now. Right click and we have to extrude it downwards. By how much? Let's check it from here. Three millimeter. Remember, you have to provide a space for the pin of the cam. That's why this is blank. Right click, pull it down by -3. As you can see, sketch is gone. Let's make it visible again. Now again select this one, select this one also, and extrude it upwards. Okay, we have to take the dimension here. So right now what we are creating this profile, this 3D profile, and this pin. So let's check, let's measure it. It's like 10 millimeter above. So let's select this, right click, press pull, 10 millimeter. Let's hide the sketch and switch on the follower. Go to head assembly and you can see two components are made. Let's hide the sketches for now. These two components are independent of each other as of now, but we will provide joints and we will provide attachment to them. Now in any case, even if you are dragging the component here and there and they are in very different positions, you can always revert them back. Now the only thing that is remaining is the pin for the follower and the pin for the cam itself. So for the follower, we need to create a hole over this one. Let it be of any dimension. Right click, press pull downwards. Now we will create a fresh component to give a pin to the follower. Let's name it pin for follower. Select this face, circle, select this one, press pull it downwards to, let's say, 25 millimeter. Obviously the operation would be a new body. Click on OK. Again activate the head assembly. We are having now 3 components. Now the only thing that is remaining is the pin for the cam. So for that, again let's create a new component, rename it as pin for cam. Click on OK. Select this face, circle command, press pull it downwards and up to where. Let's make the extend type to object, and select this one, the pin of the follower, and it will be extruded to that particular distance. Switch on the head assembly. Now we are having all the components in place. So now comes the time for visualization to understand how each and every components interacting in the assembly. So for that, let's go to this one, this pre-made assembly. As you can see, this cam is driving the follower, but these two pins are fixed. They are not moving. This follower is rotating on the pin of the follower. This cam is rotating on the pin of the cam, and we are having a relative motion between them. So as I told earlier also, we need to ground certain things. So when you try to understand this particular mechanism, you will come to know that these two pins, they are both grounded, they are both fixed. So what we will do, we will right click on the pin of the follower, we will ground it, right click on the pin of the cam, ground it. Now these two are grounded, that means I can freely move these two, the follower and the cam, but I cannot move these two. Let's revert the position. Now the follower and the pin of the follower, they are having a revolute motion. Similarly, the cam and the pin of the cam, they are also having a revolute motion. And all together the assembly is having a relative revolute motion. So what we will do, we will go to joint. The shortcut of the same is J in the keyboard. Select this face and select this point for the pin only, and give the motion as revolute. Similarly, for the cam, again motion is revolute only. Now as you can see, the pin that is supposed to revolve the follower is like protruding out of the follower. This is not desirable. So what we will do, we will adjust it somehow, so that it's not touching it. Let's check if any overlapping is there apart from this pin. I think there is none. Just adjust the pin in between over here. Now you have to capture the position. That means if I am rotating it anywhere, and when we revert it back, it will revert to the captured position that we have did right now. I think we are good to go. Now provide context to all the surfaces, and our assembly is complete. Now let's animate the model in order to see if any mistake is there in the assembly. Just go to joints, select any of the joint and animate the model. So as you can see, there might be chances that some overlapping of surfaces is taking place. So what we will do, we will press pull this just a little bit, just like over here, and now animate the model. And our assembly is officially completed. Let's hide the joints. And let's provide rendering to it. And our Geneva mechanism is fully complete. Thank you so much.